yesterday, we're going to write our list of possible rational roots. So it's plus or minus 1, 2, 3, 6, 9, 18. Can you do it that fast?
No.
No? Can you follow it when I do it that fast? Okay.
Yeah.
So let's talk about it. So the possible rational roots are all the factors of your constant divided by all the factors of your leading coefficient, which in this case our constant is 18. That's where all those numbers came from. Those are all the factors of 18 divided by all the factors of 1, which doesn't change anything. Okay, so if we did this the way we did last night, we would have to plug in 1. And we get 1 minus 8 plus 21 minus 18 is not equal to 0. Alright, let's try negative 1. And we do negative 1. Negative 1 minus 8 minus 21 minus 18 is still not equal to 0. Alright, then we try 2. So we get 8 minus 2 squared is 4. 4 times 8 is what?
32.
32 plus 2 times 21 is 42 minus 18, that's 50, minus 50 does equal 0. All right, so we found it, f of 2. Now, like you did last night, you'd be done hunting for ones that work. Because I found 1, and if I do synthetic division once, I take this cubic down to a quadratic. And once I'm at a quadratic, it will either factor or I can use quadratic formula. So I don't have to hunt anymore. The hunt is over. I choose 2. Okay? All right, so now I'm going to synthetically divide. I've got a 1, a negative 8, a 21, and a negative 18. I'm always on the lookout for any missing degrees so I can put in my zeros if necessary. I don't need to. So I'm going to bring down the 1. I'm going to multiply and do some multiplying and some adding, some multiplying and some adding, and some multiplying and some adding. And we knew we should get 0 because we just plugged in 2 and got out 0. So we know 2 is a 0, therefore it should not have a remainder. Okay, so what's left here? This is this beautiful, very simple quadratic equation that factors easily. That's a perfect square trinomial. It factors to x minus 3 squared, doesn't it?
It does.
Okay, so if I were to write the complete factorization, 2 was my first 0, and so we talked about it a second ago. If 2 is the 0, what is the factor?
X minus 2.
X minus 2. And then my other factors are x minus 3 squared. So, my first root was 2. Now, this says to classify. If it's real, it will either be rational or irrational. If it is not real, it would be imaginary. Now, 2 is a rational number. Give me an example of a number that's irrational.
Pi.
Pi,
Root 2.
square root of 7. Okay, so when we get our square roots, those are our irrational ones. Okay, so we found it's rational. 2 is rational. And then we have a double root at 3, don't we? And 3 is also rational. All right, so now let's take a look at that shortcut because you knew it was coming. Calculators.
today. It's the English quiz.
I hope you were successful.
Oh, yeah.
Excellent. Okay, so what I'm going to do is I'm going to use the aid of my technology to find from that list of possible rational roots which ones actually are my rational roots. Because if they are rational roots, they will cross my x-axis. And I can look at either my table or I can use my zeros button to calculate them. Sometimes I don't need to look at either. Sometimes I can clearly tell where they cross that x-axis. All right, so this first equation was x cubed. Typing it in. X cubed minus, get out of the exponent if you've got the newer operating system, minus 8x squared plus 21x minus 18. And just so we all have the same graph, at this point I would like you to hit zoom 6. That's usually a nice screen for us to investigate. Okay, do you see that it crosses here at an x value of 2? Do you see that it is tangent at 3? Which means it's at least a double, doesn't it?
Yeah.
All right, how can we verify? If we go into the table really quick, at 2, the function has a value of 0. At 3, the function has a value of 0. We have verified that what we thought looked like zeros actually are 2 and 3. Now, what does that mean for this problem we just did? If we had the aid of technology, it would take absolutely no work. It wouldn't. Because we saw an x-intercept at 2 that passed through. We saw where this graph passed through an x-intercept at 3, but it didn't just pass, it was actually tangent. So what does that tell me? That tells me that one of the factors is going to be x minus 2. That also tells me that x minus 3 is a factor, and because it's tangent, it at least has to be the second power. And let's count. 1 plus 2 makes 3, and this was a cubic function. We're totally done. It takes no work.
I like
Yes, sir.
Do we have a choice of whether to use the long way or the calculator way?
We are going to use the calculator way. Now, this is very beautiful when I give you all rational roots. But they're not always all rational roots. So, when they are rational roots, steal them off the calculator. If I give you a quartic and give you 2 rational roots, and that's it. Steal those 2 off the calculator, do synthetic division twice, and you're down to a quadratic, which either will factor or you can use quadratic formula for. But it really takes out testing like you had to do last night. It gets rid of all that hunting for the rational roots. It helps us find them quickly. Okay, we're going to skip to number 5 now. Punch it in and please find the rational roots on your calculator. It's a short list, you'd be looking for them anyway. Whoop, whoop, whoop. Wrong button. Alright, so we've graphed it, and I do see that I see an intercept here, and I see another one right here. Okay, it almost looks like it touches and bounces right there. It's a little deceiving though, because let's go back in and see what happens if I zoom in a little bit. Do you see that it doesn't hit and bounce right there? Kind of look like it might, but it doesn't. So, we can tell that -2 is one of our zeros. And positive and -1 and positive and -2, those were our only 4 possible rational roots. So of these 4, I can clearly see that -20 is a rational root. That is where I will begin my synthetic division. So I've got 1, 3, 1, -2, and this is number 5 on your homework. Alright, so I'll start that synthetic, and I didn't have to test anything because I used my technology. And it does work. Okay, but what I'm left with is x squared plus x minus 1. And this does not factor. It doesn't factor because there's not any more rational roots. The other roots in this problem are actually irrational. But we still have a quadratic, so we still can use the quadratic formula. So when they're not rational and we can get it down to a quadratic, then we're going to plug it into that -b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a. Oh, that was awesome. That just made my day. All right, so -b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. All right, this becomes 1 plus 4, and 1 plus 4 is 5. So this root, this crazy, ugly, irrational root, ends up being -1 plus or minus the square root of 5 over 2. So that's not 1, that's actually 2. One of them is -1 plus root 5 over 2. The other one is -1 minus root 5 over 2. And those are irrational. And then my other one was that beautiful one I saw to start with, -2. So, we have a couple different kind of factoring. We have factored over the set of integers. That would be that x plus 2 and then this thing that wouldn't factor any further. This is where it is factored over the set of integers. Set of ints. But what if I ask for that stinky linear factorization? Okay? So, how would we do that? We would say, this one doesn't change. It is linear. But this one, what I have to do with these answers is set that equal to x and work my way backwards. Okay? So let's do it. First thing we would do is multiply by 2. Y'all good with that? Next thing we would do is move the 1. And then the next thing we would do is deal with that plus or negative root 5. If it was plus, it would be minus. If it was minus, it would be plus. So when I write it like this, it becomes 2x plus 1 minus root 5. And then 2x plus 1 plus root 5. That is the weird old complete linear factorization. Okay. Now this one didn't, but what if we got right here and we were left with 1, 0, 9? What would that be? Plus 9. What would that factor to? X plus 3i. X minus 3i. Because if I took this, set it equal to 0, to solve it, we would move the 9 over and then take the square root. And the square root of negative 9 is positive 3i and negative 3i. Okay? So sometimes you might be left with something like that. All right, you have the rest of class. You can work on this. You can work together.